Hello everyone and welcome to the class of Emerging Trends in Microeconomics Research, Econ 413, lecture number 15. And today we are going to talk about the properties of the consumer preferences. There are basically 5 properties about the consumer behavior, about the consumer preferences, and they define a typical consumer. And with the help of these 5 properties, then we are able to derive the indifference curves, and we can see that how higher indifference curve can result in higher utility. So for all those discussion, it is important to understand these basic properties. If any of these properties is missing, then our entire theory of the microeconomics is non-valid, because uh, on the basis of these properties we develop our utility functions, and then while using those utility functions we derive our demand curve, and based on those demand curve we actually analyze the market, that is the supply and demand forces, and through them we derive the equilibrium prices and equilibrium quantity. But if these are not valid, the entire microeconomics then is not valid. And these properties are, the first one is the completeness. And completeness simply means that a consumer is able to make his choices, he knows his choices. Then there is a property of transitivity. Transitivity basically means there is no cyclical behavior, and he can rank his preferences in certain order, which is not cyclical. Then there is the property of non-satiability. A consumer always prefer to have more and more of certain goods. Then there is the property of continuity, and by this we mean that the consumer, he continues, once he decides that he prefers something, he prefers a bundle to another bundle, he continues that decision and is not changed with slighter changes in the baskets. And then finally we have the property of strict convexity, which basically identifies how an individual prefers averages to more. So let us discuss all of these 5 properties in detail. Let us discuss them one by one so that we can understand them properly. The first property of the consumer preference is the completeness. And how we define completeness, basically a completeness property holds that when facing a choice between any two bundles of goods, a consumer can rank them so that one and only one of the following relationship holds. And let us discuss those relationships which should hold. Let us say that there are two bundles, bundle A and bundle B, and these bundle consist of uh, two goods or maybe three goods, but let's say for simplicity purpose two goods. And a consumer is able to rank them in the following manner, that either he prefers bundle A to bundle B, or he prefers bundle B to bundle A, or he prefers both these bundles equally. So any of these three must hold, any one of them should hold. That is, he should either prefer the first bundle to the second one, or the second one to the first one, or treat them equally. There is no other option than these three, and it is not possible even for a consumer. But if it is so, then we can say that the consumer is either irrational, or he is a mad person who is unable to decide. He has no capacity of decision making. For example, we see that there is a girl who is in the shopping mall, and she goes to a boutique with different dresses, and she finds that there is a red dress that she likes. Then there is another dress, blue, and she prefers this red dress to blue. But then suddenly she realizes that she prefers blue dress more to red, and she is going to purchase that, and suddenly she again changes her decision and says that she cannot decide between the two. So all these three cannot occur at the same time. Basically, the property of completeness means that she knows whether she prefers red to blue, or she knows whether she prefers blue to red, or she knows she likes both of them equally, but she cannot choose any of these three properties, any two of these three properties at the same time, that she is not being able to make any decision about them. So that is basically the violation of the property of completeness. Then we have another property, and we call this property the property of transitivity. And we define the transitivity property as that the consumer preferences over bundle is consistent in the sense that if he or she weakly prefers bundle A to bundle B, and then she weakly prefers bundle B to bundle C, then he or she will also prefer bundle A to bundle C. So if you want to present this property mathematically, again we have now three bundles, bundle A, B, and C. A consumer, if he or she prefers bundle A to B and prefers bundle B to C, then automatically the consumer should prefer bundle A to C. This is exactly like if 10 is greater than 7 and 7 is greater than 3, then 10 is greater than 3. So it is understandable in this sense, but then this transitivity property can be violated in certain cases. Let's say an individual cannot say that he or she prefers A to B and prefers B to C and then prefers C more than A. This will make this individual insane. Although in certain other cases the law of transitivity or the property of transitivity does not hold. For example, if we talk about the cricket matches, and we have three teams, and we have India, Pakistan, and Australia, and these three teams are playing a tri-nation series, let's say, and we see that let's say India wins from Pakistan, and then Pakistan is able to win from Australia, and Australia is able to win from India. Then you cannot decide which one of them is the real champion, and this is possible in cricket. Such types of cycle is possible in cricket, but this is not possible in a consumer preference. When a consumer is making decision, and if he prefers bundle A to B and he prefers bundle B to C, then he should prefer bundle A to bundle C. Then we have the third property, which is called the non-satiability. And according to this property, we say that more is always preferred to less. So again, let me do that with a simple example. We have two bundles A and B, and bundle A has more of both the goods. Let's say that it has bundle A consists of one uh, one biryani and one Pepsi. Bundle B consists of two biryani and two Pepsi. So a rational consumer will always prefer bundle B more to bundle A. And this also defines the nature of the good as well. Whether certain commodity, whether if that is a good or bad. What is a good? Basically, a good is defined by this property, the property of non-satiability. We say that something is a good if more of it is preferred to less. But on the other hand, we call something a bad if less less is preferred to more. For example, if you prefer there is certain good X, and you prefer 2x more than 4x. In this case, this becomes a bad. So let's say how can we define certain goods? For example, there are certain food items, and food items you will always prefer more to good than more to less than that becomes a good. Similarly, clothes, they are also good because you prefer more clothes to less. Then we have money, and in this case more is always preferred to less. But let's say there is some sort of vegetable or some sort of meat that you do not like. So uh, if you do not like that meat, that becomes a bad for you. So uh, you prefer 1 unit of that to 1 unit of that to 2 units of the same meat. In this case, it becomes a bad. And what about cigarettes? In economics, cigarettes will be a good if more of it is preferred to less, and usually this is the case. So economics as a subject does not have values, but it defines things scientifically, and by scientifically we can mean that if more of cigarettes is preferred to less, then it is a good. If less of cigarettes is preferred to more, then it is a bad. Then we have the fourth property, and this fourth property is of continuity. This axiom basically suggests that if a consumer prefers bundle A to bundle B, and then the consumer prefers bundle A to C if C is very close to B. Let me repeat that mathematically. There is an individual who prefers bundle A to B, and there is another bundle that is very close to B. Then the consumer should prefer bundle A to C. What this actually does implies is that if there is a slight jump in the goods, let's say from B to C, it does not reverse the consumer preferences. Basically, by this axiom, we mean that there are no jumps in the consumer preferences, that a slight change in the basket suddenly reverses his entire decision. And we see that usually practically that when there an individual is choosing between two goods, and there he then feels that there is a slight damage in the second good, he suddenly shifts his demand for that good. So this type of behavior should not exist for the consumer. So let me summarize this point once again. We have 2 points B, two bundles B and C that are near, and there is another bundle, bundle A, which is preferable to B. Then bundle A should also be preferable to C. And then we have the final axiom, the final property of the consumer behavior, that is called the property of strict convexity. And by this property, basically we mean that the consumer prefer averages to the extremes. Let me do that by example. Let's say we have three types of bundles. In one bundle, bundle A, we have 50 mangoes. Then we have another bundle which has 50 apples. And then we have a third bundle which includes 25 mangoes and 25 apples. So basically it is taking half of each, whereas the first bundle is taking mangoes only, the second is taking apples only, the third is taking averages of the two, that is 25 mangoes and 25 apples. So which one is more attractive to you? Obviously the consumer should, a typical consumer should choose part C, because the C bundle, because it give you the benefits of both these fruits, whereas the two bundles give you the benefit of only one fruit. This one gives you the benefit of both these fruits. So C will obviously be C will always be preferred to both A and B. Let us do it with another example. You are in the college or university canteen, which offers you two cans of Coke, and one bundle. One deal gives you two cans of Coke. The second deal that gives you two burgers, and the third deal gives you one Coke and one burger. So again, let's say that all these three deals have equal cost. They cost the same. Which one of them should you choose? If you take option A, that only gives you the cold drinks. If you take option B, that only gives you the options of burgers, but the third option that gives you the benefit of both. So it contains the average, and average is a consumer prefers averages more to the individual, to the extremes. So this is the fifth principle. We can discuss the implication of the final property of the consumer preference, the strict convexity. Basically, if we want to see this through a two-dimensional graph, and on which we have two axes, the x-axis and the y-axis. On the x-axis, we have apples. On the y-axis, we have oranges. Now let's say that we have two bundles. Bundle A consists more oranges and less apple, whereas bundle B consists of more apples and less oranges. So if you want to show that graphically, we have bundle A that has more orange and less apple, bundle B that has more apple and less orange, and we can see that if we extend those lines, so these two are the extremes. Bundle A and bundle B are extreme, and there is another bundle, bundle C, that is an average. And let me combine both A and B. If we graph a straight line, this is not a very straight line, but let's say if this is a straight line joining both A and B, and then we have another bundle, bundle C, that is on this straight line. This bundle C will be the average of A and B, which consists both these goods. It consists equivalent amount of apples and let's say equivalent amount of oranges. So this is the average bundle. A consumer will prefer bundle C. A consumer will always prefer this bundle C more than bundle A as well as more than bundle B. Mathematically, C will always be preferred to A, C will always be preferred to B. Means the utility or the satisfaction that we get from C is more than A, and the utility or satisfaction that we get from bundle B is more of bundle B is less than bundle C. And let's say that let's say that both these bundles, bundle A and B, gives us the same satisfaction. Then bundle C will give us more satisfaction than the two. We can also see that through another graph that we let's say this is the blue graph. We call this an indifference curve. We will be discussing indifference curve in detail later on, but at this stage, let's say that this is the indifference curve. An indifference curve consists of all those bundles which have identical utility. So bundle A and bundle B will have the same utility, and there is another bundle on this line somewhere here, that is bundle D. Bundle D also has the same utility as that of A and B. So these are equivalent, and C is definitely above bundle D. So C will have more utility than bundle D. And if we graph another indifference curve that passes through C, that indifference curve will always be above bundle C. So what is the takeaway from this entire discussion? Let us summarize all by using another graph, and we can identify through that graph the various properties and the consequence of those properties. This is again the x and y coordinate system, and let us split this coordinate, the x and y coordinates, into 4 boxes. We have 5 or 6 bundles. Let's say this is bundle A, bundle B, bundle C, call this bundle D, this is bundle E, and this is bundle F. So we have basically 6 bundles. Now using these preferences, can we tell about which of the two bundles, bundle A and bundle B, a consumer will prefer more. Bundle B is basically this midpoint, bundle A is in the first quadrant. So which one is more preferable to a consumer? If you look at these bundles, bundle A has less of Y and less of X, whereas bundle B has more of these two goods. So in this case, B is preferable to A. Then compare bundle C with bundle B. Again, the property of non-satiation. C has more of both these goods, so C is preferable to B. So we prefer C more to B and B more to A. And then there is the property of transitivity. Automatically C will be more preferable to A, and we see that it is not violated. So this point B will always be preferred to whatever is in the first quadrant. And even let's say it is on this line, let's say if A was on this line or on this line, in both cases B has more of the commodities than A. So B is always preferred to A in both these occasions. Then we have the bundle D. Now we cannot decide between bundle B and bundle D. It may have more bundle D may have more satisfaction than B, or it may have less satisfaction than B. Why? Because D has more of Y but less of X, whereas B has more of X but less of Y. So the property of non-satiability cannot be applied here. But there is another property that is applicable, and let us discuss that in a while as well. Let us also check the property whether a consumer will prefer E to B or not. So E and B, again, E has more of X but less of Y, whereas B has more of Y but less of X, and again we cannot decide between the two. Then we have point F, and F has more goods than E. F has more X and F has possibly more of E as well. So now if B and F are equally preferable, a consumer cannot decide between B and F. He likes both of them equally. Then B should definitely be preferred more to E, because F is greater, or F is more preferable to E. So this is the property of the continuity, because E and F are very close together, and if B is preferred to F, B and F are equally preferred, then B will be more preferred than E, if F is more preferred to E. If we graph this, we combine them. Let me do that to another graph. An indifference curve, if we graph an indifference curve, it will always, if we have point B, if has to pass through the basket B, then it will always be in the top quadrant where D lies, and it will always be in the fourth quadrant, the first quadrant and the fourth quadrant. An indifference curve cannot be like this, because it violates the property of non-satiability. Whereas an indifference curve that is downward sloping, it does not violate the property of non-satiability, and it also does not violate certain other properties. So basically the implication of all these properties was that it gives us an indifference curve, and basically an indifference curve is An indifference curve tells us it is a curve on which utility is constant. So I hope you understood this lecture. In the next lecture, we are going to discuss the mathematics of this utility and the indifference curves. And if you have any question, you can ask in the comment section, or you can ask through the WhatsApp group. Hope you enjoyed this lecture. Thank you very much.